My name is Yogi Sikri. I work at AWS, and I work with AI solutions. Been in the industry for 30 years. Also been in two startups, and now with AWS. I have with me Suresh Veeragoni and Shyam Kumar. Maybe Suresh, you can briefly introduce yourself. That'd be great.
Yeah. Hello, everyone. Suresh Veeragoni. I'm a solutions architect as a job profile and AI technologist at AWS. My partner in crime is Yogi. We help a lot of customers at AWS, especially with a lot of industry focus in their AI journey. I have a decade less experience than Yogi, about 20 years of experience. I've been in the big data space and AI space for the last 15 years or so. Looking forward to present in this session.
Hey, Shyam, go ahead.
Yeah, thanks, Yogi. Shyam Kumar. I currently am one of the founding members of Articulate AI, a generative AI startup, and lead our commercial operations. Prior to that, I was at Intel, and prior to that at AWS, focused on business development activities related to high-performance computing and large-scale AI systems.
Fantastic. Thank you, Shyam. Thank you for that, Shyam. So our agenda today, I'm making sure, everyone see the slides?
Yes, we can see.
Great, great. So our agenda today is broken into three sections. One, we'll start with what enterprises actually want from data, and why is it so complex, to tap into meaningful insights from data, even after like 2 decades of us working with data, and how, more importantly, how is AI kind of a game changer in how you can leverage insights and monetize value from data. In our second section, we'll look at some customer case studies on the back of how AI actually is helping enterprises to both prepare data, to get insights from data, and then to monetize data. And then we'll wrap up with some best practices. If there are questions during the session, we actually encourage Lena and Dr. Murthy, if it's possible, to take questions as we go along. I think we'll welcome that, but we can take them in the end as well. So what do enterprises want from that data? At a very holistic level, there are three primary ways enterprises want to leverage data. And it really comes down to, time and money. The first is to be able to generate new revenue from data. So we've seen a lot of ways in which organizations who are in one vertical, they are looking to tap into data, and they're looking to drive new revenue streams from that data. The second is to essentially inject data into existing and new products. So both born in AI products, as well as existing products that have AI installed. We'll talk through some examples as well. But a classic one that comes to mind is something like Slack. You have Slack Classic, but now you have Slack with AI, which actually is more than double the price of their regular product. So huge value in terms of like developing smart products. And then the third is cost savings and productivity. So how do you actually improve your business functions that's driven by data insights? So these are three key ways that we see enterprises looking to essentially derive value from data, both in terms of new revenue generation streams, developing smart products, and then cost savings and productivity. Now, what are the big challenges of why data still goes untapped? Like Suresh mentioned, we talk to a lot of customers, and we have both anecdotal as well as like researched insights of 90+% of data still going unused. We really see three key reasons in terms of the challenges for this. And the first really has nothing to do with technology. It has everything to do with strategy and business. We see a lot of customers who basically have these big data transformation projects that are underway, sometimes from years and months for sure, without knowing what the end, how will they actually leverage all of this. Instead, we see that, and thus we see a lack of strategy on how you would actually align your data to business outcomes as being a big challenge. So we are a big proponent of actually like having business drive technology, and that's one of the key challenges we see. The second challenge is the pace of data growth. You can see some data here. 90% of the world's data is generated in the last 2 years, and 400 some million terabytes of data gets created daily. This is just like an astronomical growth of the pace of data that exists. And this basically poses both a challenge and an opportunity to be able to leverage this data. The challenge, of course, is how do you process and then cheaply store so much data? And the opportunity is how do you actually leverage insights almost at real time, near real time, very, very fast. And then the third challenge we see is around data quality and trust issues. Because there are so many sources of data, there are so many types of data, quality and trust is a key challenge that exists in organizations. Again, you see a data point there that more than 65% of organizations don't really trust the data that they have to make decisions. Suresh will talk about like how trust plays and what are some of the things that AI can help to solve some of these challenges. So with these challenges, what is the opportunity? Okay, we basically want to like present an overall framework for enterprise Gen AI. Okay, and we really see three key areas of value that you derive from data. So if you see this picture in the middle, you basically see all the data that sits in an organization. And these can come from across multiple sources, multiple types, at multiple speeds. Um, there are primarily three things you need to do. One is you need to first prepare this data. And again, we'll talk about details on how you can get the best leverage to prepare the data and how AI tools and techniques can dramatically both reduce cost as well as time for preparing this data in a way that you can process it and you can leverage value from it. The second is on the right side top, once you have the data that you need, getting insights from that data. So how do you leverage insights both from a standpoint of building the smart products that we talked about, as well as creating a better user experiences, as well as generating new revenue streams. And then the third is the upselling of the data. So once you have the data, how are you able to again leverage AI, both tools and techniques that accelerate the generation of new revenue streams? And we'll take some tangible examples on all three of these that we've in most cases personally worked on as well. So with this overall framework, I'd love for Suresh to double click on like a framework for enterprise Gen AI and kind of just double click into some of the high level concepts that we've seen. Suresh?
Yeah. So what you see, it's a busy slide, but let me just kind of walk through from the left to right so that you can kind of comprehend what's going on here. Just to, Yogi, can you go back to the previous slide? I wanted to kind of build on top of that. So you can see in the previous slide, on the left side, you have preparing the data so that the data can come and land in your data lake. That data could be structured or unstructured data, different modalities. Modalities meaning that it could be, text data and lots of different types of text data, right? Structured, unstructured. Structured, you can see like JSON data. It's in fact semi-structured data and tabular data, etc. CSV files that enterprises may have, like wherever the data is coming, IoT data, right, time series data for different industries. And unstructured data is like documents, whatnot, like you have where documentation resides, or web pages, etc. And then you have lots of different modalities from the point of, like, you have image, audio, video. And since this is a big data conference, that most of you are coming from that background of, like, all this time you've been collecting this data. If your organization is already collecting lots of data, then that means you are accruing all of that gold investment, ready for maturity to utilize that to get better insights using AI. So that's where the data is coming from, preparing, and then you're trying to get insights from that data, either using AI or traditional BI mechanisms. And then, okay, now also monetize that data. Now let's move on to the next slide. So how do you get the data so that you can, that data be ready for monetization, ready for insights? So you can see that existing data sources like your applications, clickstream data, or your logging data that even users are using. Industrial IoT is generating time series data. Or you could have vendor data, right? You could be purchasing some data from for your organization. And additional data sources, like you can see all the different kind of modalities that I was talking about, mostly unstructured data, email, transcripted audio, which is text, etc. Now, the second layer is data ingestion layer, where you have any enterprise tooling that is available, which has connectors to these different data sources. Basically, tap into those sources, whether it is batch process, like nightly connecting to the data and getting it, or real-time streaming. And then that is also another opportunity, like mostly for clickstream or IoT, etc. And then the connectors basically collect the data. And then the key thing to remember is to make sure that the raw data gets stored and persisted in an environment where you can store it for long duration without costing much, and reliable, meaning like you cannot lose that data, right? Because let's say real-time data, once the data leaves the source, then it's gone, right? And if you fail to persist the data for longer time, and your storage is not reliable, then you are losing that data. It's never going to come back. It's like a person died, right? Something like that. So it's important that keeping the raw data. I was listening to Smugmug CEO presenting at this reInvent yesterday, and he shared very good insights. Like, maybe we can post the link for that talk in the chat. The biggest lessons that he learned hosting 50 billion images and then serving customers across enterprises and consumer. And then he talks about very important thing is about storing the raw data, how it kind of came as a biggest asset for them, so that they can identify patterns in the user behavior on which users are actually paying users, which users are not paying users. And with these acquisitions from Flickr, they were able to kind of identify those patterns because they have the data, right? A lot of customers, like especially on-premises customers, are scared to store a lot of data because it's very cost prohibitive, and reliability is a big problem. So that's why you need to have a robust data lake platform where you can store all kinds of data, whether it is structured, unstructured, different modalities, reliably at cheaper cost, and you can able to process, you can able to apply security, etc. So in the middle layer, what you see is the data governance piece, where you need to make sure that the data that you are storing is good data quality. And then you need to maintain privacy. Different industries have a lot of regulations on personal identifiable information or credit card information, etc. Right? So it's sensitive information that you don't want wrong hands, other criminals, or even your own admins that you probably don't want them to see for regulatory and compliance reasons, right? So you need to make sure that wherever this data is stored, you are maintaining those privacy and data access controls so that the right users have right type of accesses, right? Accessibility is important, but at the same time, you need to persist reliably. So in the middle, you see you store the raw data, and then you can extract information from it for different business outcomes that you are planning to employ. And then the governed content comes from the data governance pieces that you are employing on the top. And then the data processing is where, like, once the raw data is stored, you process the raw data for different use case specific. And this is where Shyam will dive deep into, what Articulate will provide as a platform capability once the raw data is stored, how their platform will kind of enhance a use case driven approach by, once the raw data is stored, how you can use AI to, enhance or enrich value from the data that you are collecting. So now we finished with the data lake piece where raw data is stored and we are pre-processing, etc. Now on the right side, this is very specific to value extraction using Gen AI or AI in general. So the data processing is like where the raw data you have, how you are prepping the data for both training the models as well as validating the data. So let's say you have 1 million records. Okay, use 80,000 records for training the model and 20,000 records to test the model, right? Let's say you're doing some forecasting, predicting the failures of a tool. And then you feature engineering is which basically about like which data points are important, which data points are statistically driving the behavior, whether it is home sales or loan applications, or whether it is a tool failing, right? So that is the feature engineering part where you're processing the data to extract the significant features that you need to account for. And vector data management is something relatively new in the last 2 years where the data is persisted semantically so that the vectors of the data is stored so that when you look in for that information, you can extract information, whether it is structured or unstructured, that you are getting relevant pieces, not just traditional text-based search, but more semantic, the meaning-based search. So you use a kind of embedding, a model called embedding model, where you take the data and pass through that embedding model, and the embedding model spits out the vectors, which is basically a bunch of array of numbers where you can find similar information. Now, that is the data processing step to prep the model. Then you either train the model or you from the ground up, or you might have a model that is already available, whether it is a Gen AI model, whether it is a traditional model. You build the model using the data that you extracted. Or you could fine tune the model, right? You already have a model that is out of the box available, something like Llama. You could fine tune it, etc. And in context learning is something like an alternative to fine tuning, where models can learn by providing the data examples in the context. Like, you ask the question and then you also give a bunch of examples, like here are the, if this is a question, this is kind of the answer. If this is a question, this is a kind of answer. So you're just basically preparing the model without fine tuning with all these examples. And that data is also prepared during the data processing step. And finally, the consumption side, okay, now that you have a model, that whether it is an embedding model, whether it is a image understanding model, because your data source is image, your data source is audio, then you have an audio model, etc. Then how you consume that model, which is typically we call in the machine learning world inference. And that inference could be coming in any shape and form of application, whether it is generative BI application, whether the user is asking a question like, what is the sales data looking like for last year? So it translates that question into a SQL query. The model is actually generating the SQL query for that question based on the context, and then executing that. And then once the results comes back, then it is deciding on which visualization it needs to put, whether it is a pie chart, whether it is a bar chart, etc., and then showing that data. So generative BI is all about that. Something like Amazon Quick Site, you can see like where the capabilities are. You ask a natural question and then kind of shows the information right in front of traditional BI, where you go through a process of like, ingestion and then coming up with the UI and then data analysis, etc. Versus like all the data is there. You have a model that can understand your data. have access to the data, and you just ask the question and the insights come right in front. Very powerful, right? Time to market is very fast. And GenAI apps, I know lots of GenAI apps, like you can think of like chatbots to even apps powered, even the Zoom application that you are seeing, right? Right. Yeah, you could have a plugin that actually taking the data, transcribing it, and then getting meeting note summarization. And this is a real-time streaming data that we are talking here, right? So there, you can see like if Zoom has an application that enterprises are using, you have real-time transcribed data that is coming from the left data source. And then all of this data could be stored, persisted in a data lake as this meeting. And then you already have a trained model, which could be like something like Nova, etc. And then you have a GenAI app. The app, it could be existing app, something like Zoom, where it is actually calling the LLM with all the transcript to get the meeting summary. So that's just one example. And B2C is also, like you can see Gemini or ChatGPT, all these kind of applications are B2C applications. One thing that I missed in this one is the data capture, like, as you are getting the data between, as you're building the model, that you're putting the human in the loop so that you can properly annotate the data, and then you're able to, feed the data from the conversation history back into the data lake so that you're always continuously learning where it is appropriate. So I hope that clarifies on the different blocks in this one, having a modern data architecture. Let's go to the next slide. So in this one, I'm kind of connecting the dots between what Yogi presented in the beginning. In this slide, let's move from the right to left. So you can see the data ingestion, which is batch or streaming data. And then once that data ingestion goes into a data lake or a data warehouse, data lake is typically you store both structured and unstructured data. Data warehouses typically you store more like a columnar storage because you are doing a lot of aggregations across millions of billions of rows. So it's meant for some structured data. And then the data processing is like once the data is loaded, then you are processing the data for very use case specific, right? You are pre-processing the data. And then once that pre-processing is done, either you are creating vector embeddings on the blue box, or you could be creating more of a enriched graph kind of models, like which Shyam will dive deep into it. Or you could have real-time events that could be happening, and then you're feeding that data back into the data lake, right? And then you must have a data governance across these layers to make sure that you are able to discover the data and that you are able to apply quality to the data, and then right people have right type of accesses, etc. And that need to be kind of governed. So this is the behind the scenes piece for a GenAI app. And then GenAI app is actually using in-memory cache to make sure that it's performant is not always going back to the backend. And then this app, if it is a chatbot, like the conversation history is stored and you're augmenting the data with the enterprise content, like this is where you can think of like a RAG application, retrieval augmented generation, and then vector embeddings of the data, that's semantic, etc. And ultimately, you are using a model, a GenAI model, which is kind of acting as a brain to kind of synthesize the information on what user is asking, what data that it is fed, which is the context, and then finally responding back to the user. So it's just a kind of a zoom out picture of the GenAI app that I just previously talked about. Okay, so let's go to the next slide. So AI for data preparation. So can you go back? Can you go to the next slide? Next slide, Yogi. Yeah. So how do you build trust with your data, right? We typically talk about garbage in, garbage out. So you must have better data, so good quality data, plus then that leads to better outcomes. So what goes into good quality data, right? So having good labeling of the data so that you are building, which is good data, which is bad data. And then having lots of volume is important, and also variety is important, right? Because if you don't have variety, you have bias in your data. So you are not able to handle lots of different cases. So that is the diversity piece that you're talking about, right? And if you have less data, then you may not have enough information. Typically they have less diversity. If you less data leads to less diversity as well, right? So you need to have a good balance between you know good volume and diversity. And then you also need to make sure that if you are serving customers across different diverse backgrounds, you need to make sure that it is representative of all the people and all the type of customers, right? The fairness is important. And then you need to make sure that when you are creating the data sets, especially like synthetic data that you are creating, you need to make sure that it is accurate, it is statistically significant, it is relevant to your use case. And those are the important things. And security is always paramount. You need to make sure that this labeling kind of helps you, like this data belongs to this group, this organization, these type of roles will have access to this data. So those all will be kind of taken consideration as you build data lakes, so that the right type of security and privacy and governance controls that you can employ. So these are some of the things like a tree structure that we are putting together. There are AI tools that helps, like something like Glue data catalog can help you to kind of automatically catalog the data. It can build the metadata about the data, enriching the data. So a lot of traditional tools are adding these AI capabilities so that you can automatically annotate data and then put the human in the loop so that they can verify, etc. SageMaker as a platform also another big um, platform tooling that can help as you prep the data to build trust from your data. Okay, so let's go to the next slide. So here is a use case about Rocket Mortgage on how they were able to kind of improve their data ingestion from just what it used to take like 4 to 8 weeks to 2 hours, by using a good data lakes strategy that I just mentioned in the previous 2 slides, right? So what they built is like a connectors to different structure and structured data paths that they have, and then they were able to ingest like 10,000 terabytes of data that from on-premises, and they were able to migrate and have a data lake architecture on S3, and then able to get these productivity enhancement, especially from a data ingestion standpoint. You can find more information about this in the link that is shared. So typically, this is one important change that have happened in the last decade, where ETL is very famous in terms of like especially you have a BI application or any type of enterprise integration. Typically, ETL tooling that comes into play where you're extracting the data from the data source and you're transforming the data for your use case specific, and then storing in a tabular form typically, right? And then you start consuming it through BI dashboards, etc., something like Tableau, etc., right? That worked well for when the structured data is the only type of data and real-time data is not there, right? Those kind of things. But what happened is like with big data evolving, where we have volume, variety, velocity, exploding volume, lots of data, variety, all modalities of the data, different structured, unstructured, streaming data. Velocity is like very fast, right? Like industrial IoT. If you transform the data prematurely, what happens is like you are losing all the original data. And let's say you are extracting, let's say a tool is collecting like 1,000 parameters. Let's say a oil drill equipment, it is drilling under the ocean bed and it is collecting 1,000 parameters. In order to predict the failure, maybe you think like it's only important to capture temperature, pressure, and some significant parameters. So you transform the data, extract only the things that you need, and then you store it. What happens is, like, since you stopped collecting stopped storing the data, which has like all the 997 parameters, which could be affecting, you could use employee AI to kind of find, okay, what else could be causing, what is the correlation, etc. Right? So if you transform prematurely, you will lose that forever, right? So that is a problem with transforming before loading. So if you go to the next slide, you can see where with the ELT, you first extract, you just flip it. You extract the data, and then first you load it, whether it is structured, unstructured, streaming, batch, whatever the modality type of data, you first extract it and then load it in a data lake, and then build the trust around the data using good governance structure, and then do the transformation based on the need basis. So you always have the raw data as is, and then you extract value from it, and then you keep discovering more and more based on the use case specific. So this is the pattern that gets shifted with the introduction of data lakes, where you can store all sorts of data. So with that, I'll hand over to Shyam to kind of further dive deep into how Articulate would also help.
Absolutely. Thanks, Suresh. Yogi, if we could go to the next slide. Yeah, we want to mainly talk about this one case study here, which actually aligns really well with what Yogi was mentioning before. Because one of the challenges Yogi highlighted was, how do you improve business functions with data and AI? Or in other words, how do you take your data and AI strategy to align with business outcomes? So this is actually one good example of that. And it's a publicly referenceable case study where Intel was looking to improve their manufacturing processes. Now, just from a background perspective, semiconductor chip manufacturing is an extremely complex process and dynamic process, requires a lot of constant monitoring, analysis, and optimization of all of the manufacturing processes in these plants. These manufacturing plants are also extremely expensive. They cost billions of dollars, and any machine downtime costs potentially millions of dollars per every hour of downtime. So, and identifying the root cause for the downtime is extremely complicated. It's also a very manual process, and depends also on the engineer or technician's work experience, and because of which they might be able to quickly resolve the issue, or if somebody is not that experienced, it could take much longer. So that's the challenge they were dealing with. They were also dealing with a lot of different types of data, structured data, unstructured data, time series data, machine logs, documents, data from manufacturers, equipment, documents, and so on. So really the question was, how can I diagnose and resolve any type of manufacturing problems quickly? And what they decided to do is partner with Articulate to develop a incident assistant. And what this assistant is it's a Gen AI-based solution where essentially we took, or Intel processed decades of structured and unstructured data coming in from different sources, as I was mentioning. So machine logs, knowledge-based articles, decades-old knowledge-based articles, millions of wiki pages that they developed over decades again, and also real-time data coming from machine logs, so time series data. So the question was, how do I couple all of these different disparate data types and data sources? And how do I quickly come to some kind of a resolution for accelerated solving of the incidents? So they deployed Articulate's Gen AI platform in their own environment. This actually aligns very well to what Suresh was mentioning before about data security. And once they connected all the data sources to the Articulate platform, Articulate's platform autonomously made all the connections between the data sources and built in an automated fashion knowledge graphs that connects all the data, extracted the entities of interest, and created the logical connections, the semantic connections, and some of the things that Suresh was mentioning before, like the newer paradigms, like vector embeddings and that enable you to do contextual semantic search and so on. And once this was deployed in their environment, let's say, an engineer or maybe a plant manager or supervisor can then quickly go and interrogate and figure out, based on past history and current data, what the potential resolution could be. For example, they might be able to ask a question like, if there's a potential leak and that's contaminating the equipment, how was it resolved previously? Is there something new we could do quickly to resolve that today? And so the GenAI system goes back, looks at that previous history, takes the current data that's coming in almost real time as well, couples the two, and then gives you a potential resolution for the problem. In some cases, Intel is also able to kick off autonomous agents that actually go and automatically resolve the problem as well. And this was deployed now in one major Intel plant, and also going to be deployed in other plants in the future as well. But the interesting thing here is really the time that it saves in terms of resolving this problem. And what we've heard from Intel is potential savings of thousands of hours in highly skilled labor productivity time, also potential savings in millions of dollars in equipment downtime costs per year. And really the goal is overall manufacturing efficiency improvement. This is one good example of large enterprise leveraging data and AI to solve a real business problem that's helping not only with productivity improvement, but also saving them millions of dollars per year. And can anybody do this? Yes, absolutely. If you go to the next slide, Yogi. But the challenge again is, like Suresh was showing you, there's a lot of different pieces or building blocks that are required to build production-grade GenAI applications at scale. Can somebody put this all together? Absolutely, they can. But the way Articulate has done it, we prepackaged all these technical components out of the box. And these include some of the things that Suresh was mentioning. So embeddings, models, vector databases, generative AI or large language models, traditional machine learning models, all coming together in one package and deployed in the customer's environment. And the customer just needs to connect their data sources, the platform, and Articulate is one platform, the other platforms available as well. The platform takes care of all of the undifferentiated heavy lifting, if you will, and then gives you outcomes in terms of resolution of issues, in this case, manufacturing issue, but in a very, I would say, quick and manner and ability to provide deep insights on complex problems. And how do you do that quickly is the main challenge. And a platform like this can definitely accelerate that journey from going from data to knowledge to insights and eventually to business outcomes very quickly. I will pause there and pass the ball back to you, Yogi. And
Thank you, Shyam. I just want to take a minute and see if there are any questions so far. We've covered a lot of ground here. Okay, so moving right along.
Let me open the Q&A and not the chat. Should I?
Absolutely.
Yeah, let me open Q&A. There is nothing in Q&A, maybe in the chat. I opened that also. No, I don't see any questions for you. Suresh, Veeragoni, to everyone. Oh, he only put it in. So I don't think there's anything else.
Okay, so we move right along.
Yeah, go ahead, please.
Thank you for the Dr. Murthy. So the third pillar that we talked about is AI for data monetization. And we wanted to highlight a really cool case study here as well. This is a case study of an airline company. They are basically the biggest data provider in the world of airline data. they've existed 100 plus years since airplanes went into the sky. And what they essentially do is they collect data from all airlines and then make it available for multiple use cases. Combine the data, for example, from United Air and Continental and American Airlines and like all world airlines, and then look at the schedules, look at the combine that with multiple sources of data as well, and then give it back to those airlines as well. So that's kind of their primary business. The challenge, the initial challenge they were trying to solve was to predict flight arrival times with a high level of accuracy. For example, you are at the airport and there is a delay in the flight, or the airline needs to plan all of the gates and all of the logistics around the flight. How do you do that? So that was kind of their primary use case. What was interesting was with data and AI, the opportunity that it gave them to develop new revenue streams. And so what they've been doing is they've been leveraging advanced AI and ML for predicting flight arrival and departure. And essentially, what was a very manual outcome today for many of the customers, to look at, for example, traffic control data, how the different functions within their own organization is working. They're able to now get a AI analytics solution that can give them just a very accurate information on the flight arrival times and departure times, so they can plan all of the processes around that. Now, from a standpoint of like creating new revenue generating value added services, they are using the same data, just enhancing it a little bit, using AI, and making it available for several other verticals. For example, catering, ride sharing, travel services. So just think of a scenario where you have to basically plan for all the food that goes in the airplane, and how many people order food, etc. The catering companies lose a lot of money basically putting extra food or not having enough food. And by giving this data to catering companies, they're able to generate new revenue for them. Similarly, ride-sharing companies, think of like Uber ensuring that they have enough drivers in the airline based on events that occur. Potentially there was a big event, and lots of flights are arriving at the same time. Uber can now know that and send the drivers in time, etc. So a really big opportunity that opened for them, and this was all essentially being accelerated with a lot of AI techniques that they used. So with that, I think we can summarize what we basically shared today. We really talked about three things in this session. In terms of the challenges, but then the solutions. The first challenge that we talked about was like how business and outcomes need to basically drive how you create your data strategy, as well as where you leverage AI. And so that's, I think, the first pillar, if you will, of the outcome that we suggest. The second is that, to leverage, like, data is growing really, really rapidly. And you need to be able to basically both manage growth and also have trust in the data that you are managing. And Suresh shared a lot of like examples of tools and technology components that essentially enable you to both derive value as well as establish trust with both AI tools that are able to, for example, get quality in the data, do very quick labeling, as well as get insights from the data that is able to handle with the high growth and then the high trust that you need. And then thirdly, the data challenges again is solved by three approaches that we discussed today. One was like seeing how ready your data is, and then based on that, basically like establishing a set of tools that can tap into that. And you heard how Articulate is a platform-based approach to be able to tap into that data. And then a second approach is, the data transformation, framework that Suresh mentioned or shared, which is how you need to be able to get the data rapidly from multiple sources, tap into your data sources, create value from that, and then be able to transform it. So basically, the E, followed by the L and then the T. So the transformation happens after the load and the extraction. So this summarizes our session.